Doing Unit 5, Day 4 today, which means we are finishing up the unit on triangle and triangle congruence. The standard that we are addressing today is proving theorems about triangles. So we are still proving theorems about triangles today, just like we did yesterday. So yesterday we proved that triangles were congruent by the method of side, 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 and side angle side. And then when we had a right triangle, we could use hypotenuse left. Correct? Okay. So today we're going to add two more theorems that we can use to prove that triangles are congruent. And that's going to help us do some proofs about triangles and to find if triangles are even congruent with each other. And then we're going to also use our corresponding parts of congruent triangles to prove that certain specific pieces of the triangles are also congruent. All right, so on our theorem handouts, let's find angle, side, angle postulate. Can y'all tell me where the angle, side, angle postulate is? It's on the back side, isn't it? Okay, so on the back side, angle, side, angle congruence postulate says if two angles and the included side, now what did we learn included mean yesterday? What did included mean yesterday? In between, okay? So if two angles and the side between them of one triangle are congruent to two angles and the included side of the second triangle, then the two triangles are congruent. So this is like side, angle, side, but this time it's a side between two angles. Do y'all see the difference? So it's angle and then the side between them and then another angle. So if this figure that's on the screen, angle A is congruent, let me scroll a little bit. Angle A is congruent to angle D, and angle C is congruent to angle F, and the sides that are congruent to each other are the segment DF and AC, which are between the two congruent angles. Okay, so remember, included means between them. All right, so a side is sandwiched between two angles. All right, y'all with me? Okay, so that is angle, side, angle. All right, so we can say that two triangles are congruent if two angles are congruent and the side between them. All right, next one, y'all find angle, angle, side. Angle, angle, side. So this is our fifth and final way to say that triangles are congruent. And that is the angle, angle, side congruence theorem. So if two angles and a non-included side, what do you think non-included means? It's not in between it, so it's outside the two angles. So consecutively going around a triangle, you have an angle, then you have another pair of congruent angles, and then you have a pair of sides congruent. So non-included means it can be outside. All right? So if you have two angles and a non-included side of one triangle congruent to two angles and a corresponding non-included side of a second triangle, then the triangles are congruent. So if you can see on these triangles, A, B, C, and D, E, F down here, A and D are congruent to each other, angle C and angle F are congruent to each other, and side BC is congruent to side EF. All right, so the side is not between the two angles. So angle, side, angle has the side between them. Angle, angle, side, the side that's congruent is outside the two angles. So you can have angle, angle, side, but you cannot have side, side, angle, or angle, side, side. Does that make sense? Makes sense. Okay, no ugly words in math class. We do not have angle, side, side. All right, so here's an example. And y'all can just look up here with me. Can everybody see it? Which congruence postulate or theorem could we use to prove that triangle RST, which is this triangle to the left, is congruent to triangle VUT, which is the triangle to the right? Now, is there something that's congruent, obviously, that is not marked on this picture? The vertical angles. Y'all see that? Vertical angles are always congruent whether they mark them for you or not. So angle T is congruent to angle T over there. So which one of our 5 congruence postulates and theorems could I use to say those triangles are congruent to each other? Right, because I have 2 angles and a side, right? So if I have 2 angles and a side, it has to be angle, side, angle, or angle, angle, side. Y'all see that? Y'all see that? Count them. I got 2 angles and 1 side. Now, if the side's between the 2 congruent angles, it's angle, side, angle. If the side is outside of them, it's angle, angle, side. So is it inside or outside? It's outside of them because it's angle, angle, and then side. Okay? So it will be angle, angle, side. So sometimes counting how many angles and how many sides you have congruent will help you narrow it down. Does that make sense? Does that make sense? Any questions about that? Good job. So look for vertical angles. Okay, we're going to stop right now and work on a handout together. So this handout, we're only going to do the front page. Okay, so we're going to do the front page of the handout. And it's going to have some figures. There's 12 figures. And you have to tell which one of these 5 congruence postulates or theorems you would use to show that those triangles are congruent. So look for reflexive property when they share a side. Look for vertical angles. Look for something telling you that the lines are parallel to each other. Okay? So as a group, that's why you're in a group. Also, notice that on your sticky note with your names on it, there is a number beside your name. That number beside your name tells you what your job is. Okay? The pink sign on the board has the 3 jobs. Okay? Does everybody have a worksheet? Okay, y'all take about 8 minutes on this worksheet. So at 10:28, be ready to go over it with me. So all you're doing is telling what reason you can say those triangles are congruent. Now, it might not be possible. So they might not be congruent. You might not have enough information to say they're congruent. So tell me if it's side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg, or not congruent. Look for where they share sides. Look for vertical angles. There's some of them that could be more than one. So that's not confusing at all.
Or whole numbers, there's many different categories, but they can't be decimals that don't have a huge pattern. And what we're looking at is your what I feel.
Well, look on number 12, you see those parallel lines. So there's a little extra for you.
And we're gonna go to number 14. And then we're gonna come back to number.
Remember, you can have angle, angle, side, but you can't have angle, side, side.
So this one's gonna have brackets and labels. This one looks a little bit different than what we think. But if we look at this problem, I see an entire arithmetic that is squared. Y'all agree with me? So this right here that outline in yellow is gonna be a squared term. So if we were to get that yellow term by itself, what would it be? Now we can't distribute because that binomial is squared. So if we want to get rid of that 2, the only other option would be to divide them. Because that, to me, that's like an equation with 2x is related. You see what I'm saying there? Okay? So if we divide by 2 on both sides, we get the quantity X minus 2 squared equals 9. So
Now holler at me if y'all get stuck on one. There's some of them that can be more than one.
2 cannot be cut because it's in parentheses. Does that make sense? You can only cut it with parentheses. So now we have the square root by itself, which is positive number. Square the square root of both sides, and we get X minus 2 equals plus or minus 2. Now, we're not done at this point. It's not quite finished.
You're doing a great back. Hey, I recorded my lessons on recording, so I got you. You won't miss a thing. Hey. All right, what are those little arrows mean? Not what are these little arrows? They're parallel lines, right? So if they're parallel lines, you have all those parallel relationships, right? So you got alternate interior angles, corresponding angles, alternate exterior, all that good stuff. So it might help when you have parallel lines. Can I borrow your pencil? Sometimes it helps when you have parallel lines if you make the lines a little longer. So if you have these lines longer, this is a semicircle, then aren't these corresponding? But that's the corresponding. Okay, so then what kind of relationship do you have in those triangles then? Yeah, the sides between two congruent angles. So that would be angle side. Does that make sense? So sometimes when you have those parallel lines, draw the lines a little bit longer. Because correspondings are kind of hard to see on these pictures.
Okay, so if we look at the directions that are.
Refer back to your theorems handout if you need to.
So what we did last Thursday, we can find out, that's kind of the exact solution, and we're at all right, so we have an equation of square minus six equals 0. If the square turned by itself, nothing is not, the very first thing you have to do is add 6 to both sides. You get X squared.
Work on 6 a little bit more. It is possible.
Now X squared by itself.
6 is possible.
X squared root of both sides. What's the square root of X? Now, 6 has
Here's your hint, guys. There's only 2 of them that are not congruent. There are only 2 problems that have triangles that are not congruent, or that you can't prove congruent.
Number 7.
So these are the problems.
I mean, you have not congruent. There's another one. Yeah, because you don't have 2 pairs of angles, right? So you just only got 1 pair of angle on one side. So that's not enough information.
It's 2 and not including.
Very good. Timekeepers, how much time's left? Y'all need a little bit more time? Okay. This is kind of important, so it's okay.
If you want to watch the
Well, I don't know about anything. I just know there's 2 of them that are not possible. Question on the how many pairs of angles are congruent? You only got 1 pair of congruent angles and 1 pair of congruent sides. So do you have enough information there? No. So that one is not going to be one that's not congruent. Yeah. And why is this one not? Yeah, and you can't use angle side side, right? No angle side side, no customers and math customers. I can't write it backwards. I write it backwards. Yes. Well, good. Try, good.
Got a great golden shot.
All right. Number 6. Draw those parallel lines longer and you might can see it. And no, those lines are parallel. You have all those angle pair relationships corresponding, consecutive interiors.
Alright, so our first, the one with fabric, those are called exact solutions. And then what we just found.
All right, let me get my worksheet up.
Now, you can find exact solutions. You probably.
All right, one more minute, wrap it up. If you have one you can't figure out, we're about to go over them, or you can call me over to you. Okay, you're good. You're good. Draw those parallel lines out longer, that helps. And then these are the parallel lines, and that's your transversal. So they'll both have a relationship. It'll be congruent because they're corresponding, right? There you go. Does that make sense? You draw, these two lines are the lines parallel. So this is the transversal, so these lines are gonna be corresponding, are those angles. Yeah. Good job. Everybody good? Okay, y'all help me out on number one. Is there something on number one that you can say is congruent that's not marked in the picture? The side they share in between them, right? Everybody okay with that? Okay, so you have two angles and one side. So that means it has to be angle, side, angle, or angle, angle, side, right? Now, is the side between the two angles or is it outside them? It's between them. So what's the reason we can say number one is congruent? Angle, side, angle. Very good. Very good. Number two, is there something congruent that is not marked? What is it? The side. They share this side. Oops, I erased myself. They share that side. So I've got three sides congruent to three sides. So what reason are these congruent? Side, side, side. Very good. Any questions about that one? All right, number three, they're not conjoined together. They're two separate figures. But is there enough information to say on number three that these triangles are congruent? By what reason? Angle, angle, side. Two angles, but the side is outside them that's congruent. So this one is angle, angle, side. Pretty straightforward. Is everybody okay with those? Thumbs up if you got all three right so far. Great job. Great job. All right, number four. So I've got, what kind of triangles on number four? Right triangles. Okay, that's important to note. And what else? Is there something else congruent that's not marked? The middle line, the middle segment, right? They share that. What is that segment for both triangles? Be the hypotenuse, wouldn't it? And we got a leg congruent to a leg, and the hypotenuse is congruent to each other. So what reason would these be congruent? Hypotenuse leg. Now, sometimes when you have a right triangle, you could use another reason. All right, but on this one we couldn't because we would have angle side side, and that does not exist. Right? Right. So sometimes right triangles you could use something besides hypotenuse leg. If the angle, like say that you had the two legs congruent instead of a leg and a hypotenuse, all right, then you would use side angle side. Okay, but you couldn't use angle side side, obviously. All right, good job. Number five. Is there something congruent on number five that is not marked? There's a pair of vertical angles in the middle, right? They both have that same angle measure congruent. But are these triangles congruent? We don't have enough information to say, right? Because I've got two sides and an angle, but the angle is not between, and we said that angle side side does not exist. Right? Right? No cuss words in math. So these are not congruent. Raise your hand if y'all got that one was the one that was not congruent. Very good. I believe if any of them gave anybody trouble, I believe it was number 6. Y'all agree? And you just had to think about it. So first of all, what do these little arrows right here mean? That those lines are parallel. Now sometimes when you have parallel lines, it makes sense to kind of extend them a little bit longer so that you can see that those are parallel lines and this segment right here is a transversal. Y'all see that? So two lines cut by a transversal. We have all kinds of linear pair relationships and angle relationships that we learned in the last unit, correct? All right. So if those are parallel, then we have alternate interior angles congruent, corresponding angles congruent, alternate exterior angles congruent, and consecutive interior are what? Supplementary. Very good. Now, so I do that. Aren't these angles right here corresponding angles? Yeah. So I can say this angle right here is congruent to this angle right here. I've kind of used my marking. So that side's congruent to that one. So what do we have? Angle, side, angle. The side is between two angles, right? So angle, side, angle. Is everybody okay with that one? Everybody okay with that one? That one I think was the most tricky, okay? Because it's kind of hard to see those corresponding sides. All right, number 7. Is there something congruent that's not marked on number 7? The side they share in the middle. So this one is congruent by what? Very good. Side, angle, side. Number 8. Is something congruent that they don't have marked? Yeah, the segment in the middle. So these are congruent by what? Side, side, side. Number 9. All right, automatically it looks like what? Hypotenuse leg, because I have a leg congruent to a leg, the right triangles, and the hypotenuse are congruent, and that is correct. Is there another reason I can say those are congruent? Yeah, because if you look, these are vertical angles, aren't they? Right? So I've got this angle, and then right angles are congruent, and then a side. So I could use angle, angle, side as well. So either one of those would be correct. Raise your hand if you mark both of them to start with. Y'all are awesome. Y'all are awesome. But a hypotenuse leg is absolutely correct, and it was pretty obvious on that one. Number 10, is there something congruent that is not marked? Vertical angles. Always look for those. So are these triangles congruent? By what reason? Angle, angle, side. Very good. I think that's all you could do on that one. Number 11, is there something congruent that's not marked? They share that segment, correct? So reflexive property says it's congruent to itself. So I only have one pair of angles and one pair of sides. Do I have anything else that's congruent that we know of? No. So can I say those triangles are congruent? No. So that's our other one that's not congruent. Not enough information. I need another pair of sides congruent or another pair of angles. Number 12, what do those little arrows mean? Those are parallel lines, so I have all of those parallel relationships. All right, first of all, the vertical angles are congruent, right? Right? But that would give us angle, side, side, which doesn't exist. So I need to use those parallel relationships, correct? Correct? All right, because we don't have angle, side, side. So give me a pair of angles that are congruent to each other. There's actually 2 pairs. Okay, if I mark this one, is it congruent to something? This one down here, because what is that relationship between these 2 angles if those are parallel lines? Alternate interior angles. So do we have something when I do that?
Side, angle, side.
Side, angle, side. Okay. Good. That's one. I also have, since I have vertical angles, don't we have angle, side, angle? Right? Aren't also these congruent because of the same reason? Alternate interior angles? Yeah. So I could also have angle, angle, side, couldn't I? Right? If I do angle, angle, side. So that one had 3 different ways I could say those are congruent. Right? Right. So if I was doing a proof, I could use that one lots of ways. Very good. All right, back to notes. So on your notebook paper, write this down. We already talked about this in our intro last week to corresponding parts of congruent triangles. But congruent triangles have congruent corresponding parts. Okay? So there's a rule in geometry that says corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. So after we have stated, like as a statement part of a proof, that two triangles are congruent, we have written our congruency statement because we practiced that earlier today. Then we can say that specific segments are congruent to each other or specific angles are congruent to each other based on corresponding parts of congruent triangles are congruent. Now, y'all, we're not going to write that for a reason because it'll take all day. So we have an abbreviation for that statement, and that is CPCTC. Memorize it. CPCTC means corresponding parts of congruent triangles are congruent. CPCTC. So you can use CPCTC as a reason when we're doing our proofs. If your final thing you're trying to prove is that an angle is congruent to another angle or a segment is congruent to another segment. Okay, so what we're doing in this unit is proving theorems about triangles. All right, so another way we can do that if we're proving that specific angles or segments are congruent, we can use CPCTC. Corresponding parts of congruent triangles are congruent. Okay, you cannot use CPCTC until you have in fact proven the triangle's congruent by one of these 5 reasons. Okay, so you have to use one of these 5 reasons right here to prove your triangle's congruent. And then after you say that the triangles are congruent, then you can use CPCTC to show that specific sides match with each other or specific angles with each other. And that will make sense after we do it. But write that down. You must prove the triangles are congruent first. You have to say the triangles are congruent first before you can use CPCTC as a reason.
So you can understand that better, that's fine, but you don't have to rewrite that. Are we good there?
All right. Here we go for a proof. Because that's what we're doing, right? Our standard for the day, using theorems to prove theorems about triangles. What do?
Okay, what do we need to do?
Sorry, I'm on your way to work. All right. So if you want to, you can put your givens in a table. But y'all, that picture kind of looks like a boomerang, doesn't it? Right? But it's 2 triangles put together. A kind of funny shape. They look kind of like obtuse triangles, don't they? All right, so this is angle QRTS, and they've also called Q angle 1 and S angle 2 for some reason. Okay, sometimes we name angles by numbers. Not my favorite, but they do it. So we're going to practice it. So when we set up a proof, we always have our statements and reasons column.
But we can't make a radical in the denominator, we have to rationalize, but to rationalize the denominator, we know the denominator
Let me give myself some space. Can y'all see all that? Bless you.
So
Now what's going to go for my first statements? The givens, right? What all is given to me? Angle 1 is congruent to angle 2. Is that all? Very good. So write all of that down in your first statement, and the reason for all those are given. That's what they told us. Now, did they mark anything congruent on the picture? No. So after we write down our givens, we need to mark it on the picture. So I'm going to mark angle 1 congruent to angle 2. And RTQ, which is this angle, is congruent to angle RTS, which is this angle. I don't know why I keep scrolling. Got my 2 tick marks in there if y'all can't see it. So I marked it. Now I'm trying to prove that segment QT, which is this segment right here, is congruent to segment ST, which is this segment down here. All right? But before I can prove those segments are congruent, I first need to prove that the triangles are congruent. Right? And after I have proven the triangles congruent, then I can say those pieces are congruent because of CPCTC. Corresponding parts of congruent triangles are congruent. So how can I prove those triangles are congruent? If there's something we know is congruent that's not marked on the picture, RT is congruent to what? RT. So write that down. RT is congruent to segment RT because of what? Reflexive property. Reflexive property states that anything is congruent to itself. Very good. So now do I have enough information to prove that the triangles are congruent? But by what? By what reason? Yeah, I got 2 angles congruent and 1 side congruent, but the side is not between them, is it? No. So it's going to be what? Angle, angle, side. Now I need to be careful writing my congruent statement. We practiced that earlier. So angle Q is congruent to what angle? S. And T is congruent to T, so that means R is congruent to R. And if you look at your statement, is QT congruent to ST? Are they in corresponding positions? Yes. So now I can say segment QT must be congruent to segment ST because of corresponding parts of congruent triangles are congruent. Abbreviated CPCTC. Corresponding parts of congruent triangles are congruent. We did a proof. Good job, guys. Okay, so if you want to prove that either 2 sides of a triangle are congruent to each other or 2 pairs of angles are congruent, you have to prove the triangles are congruent first, and then you can say they're congruent by CPCTC. Okay, got it? So if you're proving sides or angles congruent, this better be your last reason. All right, but you better have a triangle congruent statement and a triangle congruence reason before you can say CPCTC. All right, let's do another one. All right, there's another pretty picture for you. Kind of looks like a kite. So draw the picture, and if you want to, you can put your given in your table, your statements and reasons table. Okay. Open it, yeah.
What?
And then send you guys tomorrow, okay? All right. So statements and reasons. Making our table for our proofs. Hopefully y'all drew your picture better than mine. Y'all can see where I boo-booed it. Always. It's terrible. I know. All right. What's my first statement? What's my first statement? The given. segment GK bisects angle FGH and angle FKH. And the reason for that is, what's the reason for my first statement? That's given. That's always my first reason. Always. And like I said, sometimes people split up givens, but this is just one sentence. Okay. I've told you guys before, bisects is a very important mathematical term, isn't it? Right? What does bisect mean? Cuts it in half. So if something's cut in half, it makes what? Two congruent things, right? But we're bisecting angles here, aren't we? Y'all see that? So we're bisecting angle FGH, which is all of angle G over here. And we're bisecting angle FKH, which is all of angle K. Right? So bisectors make two congruent angles. So let's just talk about angle K right here. So if angle K is being bisected, what two congruent angles does it make? I need how many letters make an angle? 3, right? FKG, okay, is congruent to angle GKH. And I can go ahead in the next one because it also said that FKH is bisected, right? I wrote something wrong, didn't I? I did K first, didn't I? GKH, okay. Now, angle G over here is also bisected, right? What two congruent angles are formed when that one's bisected? FGK is congruent to what angle? HGK. And I'm going to mark those. This one's congruent to this one, and this one's congruent to this one. Now, what reason can I say those two sets of pairs of angles are congruent from each other? They have the same reason. Very good. Definition of an angle bisector. Definition of an angle bisector. We learned about an angle bisector in Unit 1, didn't we? Didn't I tell y'all in Unit 1 that a bisector was an important word? Yeah. All right, so now I've got two pairs of angles congruent and another pair of, two pairs of angles congruent. Right, two sets of angles. Is there anything else from this figure that's congruent? Yeah, they share this segment between them, don't they? Right, so what can I say? Segment KG is congruent to what? Segment KG by what reason? Reflexive property says something is congruent to itself. And they both share that segment. Do I have enough information to say that those triangles are congruent? Yeah. Okay, so this and this is congruent. Now, what reason are those triangles congruent? Yep, the sides between two angles. So angle, side, angle. So I need to be careful writing my congruency statement. So angle K in one triangle is congruent to what angle in the other triangle? K. And angle G in one triangle is congruent to what in the other triangle? G. And so the one has an F and one have an H that must be congruent to each other. Right? By angle, side, angle, because the side is between the two angles. So now can I say that segment FK is congruent to segment HK? FK and HK? By what reason? CP, yep, CP, CTC. Corresponding parts of congruent triangles are congruent. So now that we said those triangles are congruent, I can say they have congruent corresponding parts. And FK and HK are corresponding parts. Corresponding parts of congruent triangles are congruent. We good? Questions? It's not so bad, is it? So it's basically like one more step than what we did yesterday, right? So yesterday we proved triangles are congruent by side, 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 angle, side, and hypotenuse leg, and we stopped there. Now we're tacking on corresponding parts of congruent triangles. Okay. We're gonna do one more, and then you guys are gonna do some problems in a handout. All right. Now this time it didn't give me a given, did it? No, it told me what I wanted to prove. Segment SM is congruent to segment SQ. But it didn't give me a given. But it said use the information in the what? Figure. So we get our givens from the figure. Right? Right? We get our givens from the figure. So statements and reasons. So what's a statement I can say from my figure? Just blatantly what's marked congruent on my figure? Angle N is congruent to angle P. Anything else marked congruent in my picture? Segment NM is congruent to segment PQ. And those are all given from the picture, right? If you want to put figure out there beside so you know where the givens came from, that might help you. Is there anything else I can say is congruent in my figure? Vertical angles, right? So this angle S is congruent to this angle S, right? So that since there's more than one angle S, I need to be specific when I name them, using 3 letters instead of just one, right? So that angle S to the left is angle what? Whoops. NS, I keep touching stuff. NSM is congruent to angle what? PSQ. By what reason? Vertical angles theorem, VAT. So now do I have enough information to say those triangles are congruent? Yep. So by what reason can I say those triangles are congruent? Yep, I have 2 angles to the side, and the side is not included. So it's going to be angle, angle, side. Very good. So be careful with your congruency statement. Like I said, congruency statements are easier when you have more angles congruent. So angle S is congruent to angle S, right? Angle N is congruent to angle P, and that means M and Q are congruent to each other, right? Now, what reason do we say those triangles are congruent? Angle, angle, side. So now can we say that segment SM is congruent to segment SQ? By what? Very good. Segment SM is congruent to segment SQ by CPCTC. Corresponding parts of congruent triangles are congruent. All right, I have a handout for us to work on. Y'all are going to like this. All right, we're going to do them one at a time. And y'all are going to like this a whole lot better than doing a whole proof by yourself. Right here, with your group, I want you to discuss with each other. And we're going to do it one problem at a time, so no jumping ahead. We're doing this all together. All right? All together. Don't work ahead. Only do number 1. Only look at number 1. And number 1 has a proof on it. Do you see it? It's got a figure and a proof. Let me show you. I have it on my screen. Somebody got the hiccups. Oh, here you go. All right, I had to put mine beside each other. Y'all might give y'all one. Is that what it is? I need one more. Okay, sorry. So notice I gave you the figure and a partial proof on number 1. As a group, I want y'all to discuss. Now they use the word justification instead of reason. That means the same thing, doesn't it? right? Justification is the same thing as reason. So I want you to find the answer choice that correctly fills in that proof. Discuss it with each other. Take a couple minutes. All right, discuss it with each other. Y'all need to make sure. Okay. Yeah. You mean sides? Yeah. You can use that side. No. You're not going to use that. You're not going to need that. You're not going to need that. You could, but you're not going to. Yeah. You're not going to need that. Okay, if they didn't mark stuff congruent, you can't just say it's congruent. Did I tell you?
See, I had all three angles.
Technically, yes, but you're not going to. Don't overcomplicate it. Don't complicate it. Use only what's given. So y'all discuss with each other, see which ones correctly fill in the blanks of that proof. So some of them you're finding a justification, which is the same thing as a reason. Some of them you're finding a statement.
So in this case, graph 10 actually does not pencil. So that makes sense, you just have actually
I'm telling you. I'm also, I'll get an answer. What do you think? I think it's B. Sorry. Why B?
It's automatically, you can see that number two, it's supposed to be reflective.
Yeah, so they try to get you confused with reflexive and symmetric there, didn't they?
Yes.
Yeah,
So
that,
that makes up A, things, yeah.
that's right. Process of elimination.
Then number three is the definition of angle bisector.
So the definition of angle bisector of angle MTR told us what two angles are congruent. Okay, also, did you notice that like A and D said segments are congruent? Yeah, so if it's angle bisector, we need angles congruent, not segments congruent. Does that make sense? That makes sense. Good job. And then what reason could you say then the triangle? What reason are the triangles congruent then? You got the angle T's congruent to each other. Side angle. Right, so y'all narrowed it down, but yeah, that being the angle bisector, that angle, like this one, you go to that one, and then that's each other to that. So you got the side. Very good. All right, y'all ready to check it together? Looking around, seeing answers. Looking around. I think we're all in agreement. Good job. So on number one, it says they gave you that segment MT is congruent to segment RT and AV is the angle bisector. So obviously the given is there. All right. And then they say right here on step 2, segment TQ is congruent to segment TQ. Now, what reason tells you that TQ is congruent to segment TQ? That should be reflexive property. What I would probably do when I have a proof like this on multiple choice, I would probably write it in and then go and match up later. Does that make sense? Does that make sense? Who did that? Who did that? Did anybody do that method? If it's a multiple choice problem for me, that's what I'm going to do. So that way I don't get stuff mixed up, especially when you have 3 different things to fill in. Okay, I would try to fill in the proof and then go look at the answer choices. But some of y'all did that and said that's reflexive, So that eliminates what answer choices? A and C, because they both said justification to what's the metric, and we know anything congruent to itself is reflexive property, right? Y'all are pretty good with that. So the next one says, I'm going to use the definition of an angle bisector, probably to say some angles are congruent to each other. And it told you, I need to scroll it. The AV is the angle bisector of MTR. So that means if MTR is being bisected, this angle T is congruent to this angle T, right? Right? So then you need two angles congruent. And look at D. Didn't it say two segments are congruent there? Yeah, so it's probably not going to be that. And then it said that we can say triangles are congruent by what? Side, angle, side, right? And the other choices say side, 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 because I have the included angle between two sides. Raise your hand if you got B in your group. Y'all are awesome. Y'all flip over to number 2. Number 2. Same kind of problem here. They have a partial completed proof, and y'all have to fill in the blanks. So y'all work on that with your group. I want to hear some good discussion, please. I want to hear some good discussion.
There, very good, very good.
Complete the proof.
All right, so again, it's on the whiteboard and it's on my screen, this is correct, so good job for both group members. And I'm very proud of everyone for participating, that is very good. Sometimes we struggle with our participation, don't we? And I don't know why, it's not early in the morning, it's like.
Finding 2 justifications. For 2 reasons.
Any questions on this lesson?
What do you think, Nicole?
Does one expert have to be by himself?
Why do you think, babe?
Because,
All right.
that is something that
Okay.
and then.
Because you have parallel lines. Uh-huh. So then they use angle side. Very good. Sounds good to me. Good job. Y'all agree? Ladies, y'all agree with him? What y'all say? B? Okay. So why were those angles congruent? Parallel lines, so what's that relationship? Alternate interior. Very good. Very good. You good? All good. All right, I'm walking around. I think we're in
Did you
agreement.
use angle, or did you use angle, angle?
Angle does not exist. Congruent triangles, Dr. Power, and it's only for similar triangles.
Well, wait a minute. If you know that the triangles are congruent, you can say all 3 angles are congruent.
That's not a reason to prove triangles congruent. It's a reason to prove that they're similar.
I took geometry back when God.
All right, now.
Exactly. That's why you don't remember it.
You're right. But you did mark all 3 angles.
Are you okay?
She enjoys it.
You have to have at least one pair of sides congruent to say triangles are congruent. Because that proves the same size.
But you can have 3 sides.
Yes, because they're the same size. That was a postulate out there.
Possibly not. You got me. You got me. She had 3 angles marked. I was sitting there going,
Because it was true, because you got 2 pair of alternate interior angles and a pair of vertical angles.
that's fine.
Y'all are fine. Okay. We're filling in the blanks for this proof. So I got my 2 givens. It tells me that JK is parallel to VR and JL and VL are congruent, and those are all marked. So this next statement tells me angle KJL, which is right here, is congruent to angle RVL, which is right here. By what reason? Those are alternate interior angles, right? Right? Okay, and then it tells you that KLJ, which is this one, is congruent to RLV, which is this one, because of what ring is it? Vertical angles are congruent. So what is the correct answer to number 2? B. Raise your hand if you and your group got B. Awesome. Flip to number 3. Okay. Now this one is a little bit higher order thinking, right? Okay? Sometimes it's easier to do something point blank than it is to find someone else's mistake. Right? Sometimes when y'all bring me a problem, it takes me a minute because I'm looking for your mistake if you made one. Sometimes you didn't make a mistake. Right? So that's what you're trying to do on number 3. You're trying to find out if the student made a mistake, and if they did, where they made the mistake. I know the highway. I'm going to use it. All right, look for where the student made a mistake, if they even made one. Because option D says they did not make any mistakes. What do you think? Did they make a mistake? Did they make a mistake? Sometimes the mistake is glaringly obvious. Sometimes it's not. All right. All right, what do you think? Did the student make a mistake? Well, what was the mistake? They said that RT is congruent to RT because of symmetric property. Does symmetric property say that something's congruent to itself? No. What does symmetric property do? It swaps the order, right? It swaps the order. Okay, so that should be reflected. So raise your hand if your group got B. I wish they wouldn't all been B. I don't even remember what the last one is. Okay. Now this one's a little bit different. So what I've done is I've kind of showed you all these different examples of how you might see a question from the standard on a benchmark exam, or even a state practice test exam, or a state test. Okay? Because these are going to be in multiple choice format. All right? So I hate to break it to you, you're not going to have to complete a whole proof on the state test. Right? Because they say we're all going to be in multiple choice or select all that apply format. All right? So, dang it. No fun. But nobody wants to grade that. So they started the proof and you've got to finish it. Talk to each other. Talk to each other. Talk to each other. They start it, you finish it. Take a picture of all her markers, lay down there.
Yeah, I gotta get that.
And her matching candy.
This way and I'll leave it.
What'd y'all say? Let me look at it. So you do angle. So you're drawing of angle bisector. Y'all draw it. Good. So when they tell you they do it and they don't turn on people, you always draw it.
And then so, you know, M and M are congruent as we draw it, and then what would you use after that?
You use nothing, other reflective properties.
Yeah.
Say that it's a piece of
To itself. So that would eliminate two of them, right? And then Lloyd, how could you say the triangles are congruent? Side, angle, side, because the angles are between them. Very good. You're proving elements. Very good. Very good. Yeah. You got to remember everything. Like all these sheets I've given you, every one of them. I've memorized. We don't forget properties and theorems, do we? Okay. So this one took a little bit more work. Y'all agree?
Yeah. For one thing, they told you something, but they did. I'm stuttering. They didn't do it in the picture, right? It says consider triangle LMN where LM is congruent to MN. They did mark those for you. A student constructs a point P on segment LN such that MP is the angle bisector of angle LMN. They didn't draw that line segment, did they? No. So did everybody start by drawing you a bisector from M to P? Oh, mine is crooked as a jaybird. Did y'all do it? Yeah, if they tell you somebody construct something and it's not on your picture, draw it in your picture, okay? Always, always. Draw your picture. Your pictures are important. Drawing pictures and labeling things are important. All right, so it starts to prove to us, and it has those congruent, and it says that these are congruent because of the definition of an angle bisector, right? Then what we say is congruent, y'all. Yeah, both triangles have segment MP in them, right? So that would be by what reason? Reflexive. So that means it's not B and not D, right? Right? Because they said symmetric there, right? And then it said, so then can we say the triangles are congruent? Okay. So what reason are the triangles congruent? The angle is in between two congruent sides, right? So that would be side, angle, side. Y'all agree? All right. So what is the correct answer, A or C? Angle C. Raise your hand if you and your group got angle C. All right. Any questions? Okay. So before we can use corresponding parts of congruent triangles are congruent, what do we have to do first? Prove the triangle. You have to prove the triangles are congruent by which way? How can you prove triangles are congruent?
Angle, triangle, congruent.
All 5 of these ways are ways you can do triangles are congruent, right? So what have we been doing in this unit? We have been proving theorems about triangles. All right, that's our standard that we've been working on the last 2 school days. So we're going to wrap it up. Tomorrow is study guide day, and the school day after that is test day. All right? So notice in your packet from the first handout, there are some proofs for you to practice. And we are in groups for a reason, right? So take these last 14 minutes of class, and with your group, see how many of these you can accomplish. Now, I'm available to help if you need it. I have answer keys if you want to check it. All right, so let's practice doing some triangle proofs. Some of them are more difficult than others. All right? You're not the first. You won't be the only one. That's you. So y'all work on these proofs. Some of them are more challenging than others. So I don't care where you start, you skip around. This is just practice. You will have proofs on this test. So it's important that we practice our proofs. There will be proofs on this test.